Okay, this is example number 5 for this review, and it's just Alexander number 3-2. We had a homework problem similar to this. Surprise, surprise. And what you can see is that it wants me to find V1 and V2, and those are my node voltages. All right, I have a couple options here. The first option is, of course, that I can put these in parallel, and that's probably a good idea. Let's say 10 is in parallel with 5, which means that I have 50 divided by 15, which is 3.33 ohms. All right. Alternately, what we could do is not do this at all, and let there be currents that go through each of those. Not a big deal. All right. So next we need to do our next step, which is to do nodal analysis. All right. So effectively, what I've done is I've taken these and I've replaced them with a single resistor, all right, that has a value of 3.33 ohms. Okay, so that means that for nodal analysis, step 1, which is assign, our node voltages are already assigned. I just need to assign currents. All right, what I notice is that there's a current here, which is 6 amps. All right, no matter which spot I am, that's 6 amps. I have a current going from 1 to 2 because we assume that V1 is greater than V2 is greater than 0. I set the bottom to be ground. I know that 3 amps comes in here. And then I know that through this 3.33, I've got I1 to ground. And then I've got from V2 through this 4 ohm resistor, I2 to ground. All right, so next step, step 2, is use KCL plus ohm. And I guess the word that I typically use here is apply. Shoot. Apply. All right, so let's start at node 1. All right, at node 1, I have minus I10 minus I12 and minus 6. All right, those are the things that are going out. In fact, all of the currents are going out of V1, and I set this equal to 0. All right, so now I apply the Ohm's law expression. I have V1 minus 0 over 3.33. And then I have up here V1 minus V2 minus V2. I'll put parentheses around there so we don't get confused. Over 2 is equal to 6. Okay. So if I multiply here through by, okay, well, first of all, what I can do is figure out where these are going to match up. It turns out that if I take 10, that's not a bad option because that's the first time that 3.33 multiplies into a full number. So let's multiply through by 10 times 10. All right, and so what we get is minus 3 V1 minus 5 V1 plus 5 V2 is equal to 60. All right, so this gives me minus 8 V1 plus 5 V2 equals 60. Let's call that equation 1. All right, so now let's go to node 2. All right, at node 2, what comes in? Well, I12 and 6 amps and 3 amps. So we can write that as coming in 6 plus 3 plus I12, and what comes out? Just I20. So minus I20 is equal to 0. All right, that's KCL. And we can write in terms of the node voltages using Ohm's law. So this is plus V1 minus V2 over 2 ohms minus V2 minus 0 divided by 4 ohms. All right, so now let's multiply through by 4. And what I should get is 36 and then plus 2V1 minus 2V2 minus V2 equals to 0. So that tells me that I get minus 2V1 plus 3V2 is equal to 36. And this will be my equation 2. All right, so now I'm to step 3, which is to solve. Okay, in step 3, I'm solving. It might be best, well, it really doesn't matter which thing I use. In this case, let's solve 2 for V1. All right, and when I do that, we have 2 up here. I should get that V1 is equal to 36 minus 3V2 divided by minus 2, which is equal to minus 18 plus 3 halves V2. All right, and then we'll sub this into equation 1. All right, when I do that, I get minus 8 times minus 18 plus 3 halves V2 plus 5 V2 is equal to 60. All right, so that gives me 144 minus 12 V2 plus 5 V2 is equal to 60. And in turn, then I have minus 144 minus 7 V2 is equal to 60. So minus 7 V2 must be equal to minus 84, which means that V2 is equal to 12 volts. Okay, next thing I want to do is plug that back into my V1 expression. V1 is equal to minus 18 plus 3 halves V2. All right, V1 is equal to minus 18 plus 3 halves times 12, which is equal to 0. So then V1 is equal to 0 volts. All right, and so that's how you solve that nodal analysis problem.